Before we start this video, a large thank you to uking12, Garrett, Brammy, Luca, and Simio Michael, a name I unfortunately cannot pronounce. Thank you for supporting my friend Matthew and David for their support on Patreon. I hope you guys enjoy the video. So today we're going to learn how to write a file from Unity to JSON, and we're going to use that file to save character data. So before we jump in, what are we going to do in this video? Well, first we're going to create functionality to write and to read files on your machine. And we're then going to use that ability of reading and writing data to write data if you're saving a game or creating a new game, or reading data when you want to load a previously saved game. All right, let's jump in and begin. Okay, so the first thing I want to do is tidy up my project from the last video. So I'm going to do that by placing the scripts I created in the last video in their proper folders. For me, that is under the player folder and then the player UI folder, and I'm dropping in the scripts relating to player UI. Next, I'm going to create a new folder in the scripts folder, and I'm going to call this save and load, or alternatively just call it game saving or save game. Anything that makes it very clear to you what this is. So this is going to contain scripts for saving and loading your game. Now we have the world save game manager, but we don't need to put that in there because that is a world manager. When I say game saving, I mean things to do with writing and saving stuff to a file specifically. So let's make a character save data script. This is going to house all of the data we want to save from our character, like their name, their stats, etc. Then let's make a script to read and write files on your PC. So you can call this whatever you want, whatever is clear to you. So you call it save game data writer, you can call it save file creator, as long as you know what this does. I'm going to call it save file data writer. So as it states, it's going to basically make a save file and it's going to write the data to your computer. So I'm going to open up these two scripts and erase the start and update functionality and add in my namespace as is per tradition. So let's start now with the character save data after we add in our namespaces. And I'm just going to move that over here on the tab on Visual Studio to the left so it's first. And now let's think about what we want to add. So in this video, we're probably only going to get to add a couple things. We don't need this to be a mono behavior. And why is that? Well, this is not going to be attached to any game object at all. So it's going to be system.serializable also. It's only going to be a reference for basically specific types of data. So what I'm trying to say is when we save or save or load a set of character data, we're going to use this as a template for things we want to save or load. So this is going to house basically all the stats, your character's name, its position in the world, etc., etc. So it's just basically a reference of data we need to grab. So let's start by putting in some information here on things you want to save. So I'll start by saying public string for our character name. And then right below that, let's make another variable for, let's say, total time played. So I'll make a header and call this time played. And then down here, I'm going to make a public float, and I'll just say seconds played. So we don't have much to save right now, so we can just keep it really simple. So I'll make a header up here too, and say character name. And we can also save our world position. So we need to actually place in 3 separate floats here for the X, Y, and Z coordinates. We can't save this as a vector 3. And the reason being that when we serialize this to JSON, we can only use the basic variable types. So think of things like float, integer, and string, bool, stuff like that. You can't use things that are, I would say, specific to Unity especially, but you can't use any kind of advanced variable type. So just the very basic ones. So I'm going to put a comment here saying question, why not use a vector 3? And the answer to that would be we can only serialize or save the basic variable types. Now, if you don't know a lot of this stuff already, don't worry about it because it's just one of those things that you just don't know it until you know it. So hopefully after this video, this will be the experience for you to know it and then you can remember it. So that small rules like you can only serialize basic variable types. Like these are things you wouldn't know unless you've worked with saving via JSON and stuff before. And if Unity is your first introduction to programming, then these are just things you likely just won't know. So likewise, what we're going to do next, you're going to see a lot of, I'll say, weird syntax if you never worked with saving or specifically writing files to a computer before. So don't worry about it. You you don't know it until you know it. So if this is your first time doing it, cool. If it's not, and you've experienced this before, excellent. So let's make a public string for save data directory path. And as that suggests, this is where we're going to save the file to your computer. And let's make a public string for the data save file name. I'm actually just going to change that to save file name. And as it suggests, this is going to be the name of the file specifically. So the path is where you save it, and the name is the name of the file itself. Let's say using system and using system.io. We're going to require these libraries for what we're going to be writing next. And then right below our variables, let's say public bool, and let's call this check to see if file exists. And now we're going to use this in a future episode when we make multiple slots, but we're going to write the logic now. It will come into play very soon. I'll make a comment before we create a new save file in the future. We must check to see if the file already exists. You don't want to overwrite a save file when you start a new game. You want to make sure that the file that you're trying to write does not already exist on the computer. I'm put a bracket here that we have a max of 10 character slots. So basically, if all your slots are full, you want to do nothing, notify the player they should delete one. So we're going to say if file.exists, and we're going to pass the directory path and the file name, then return true, else return false. And as it reads, this basically just checks for the file on your computer at the path, and it checks the file name. And I'm sorry, that should be if file.exists, and then that should be .combine path, I believe. So up here, we're going to say path.combine. There we go. And that is as it's written. Even I have to come back and check my notes when I write these things all the time, because I just don't use these specific libraries and syntaxes very often. So right below that, I'm going to say public void delete save file. And this is very similar again. We're just checking the path and the file name, but we're going to use file.delete path, path.combine, the directory, and then the file name. So as it suggests, we're just going to the directory, we're looking for that file, and then we're deleting it. So this is going to be used to delete character slots in the future. Character slots is actually a bad way to phrase that, because whenever deleting slots, we have 10 slots permanently. Character save files is a better way to phrase that. Okay, so we have a way to check to see if we have a file that exists. We have a way to delete a file. Now let's make a public void for creating a new file, or creating a file in general. So let's call this create new character save file. And let's open up some brackets, and let's make it require a character save data variable, and we'll call it character save data. So remember, we just made the character save data, and that just, again, stores data we want to save to our machine or load from our machine. So it acts as a template, if you will. So when we create a new save file, we need to hand it a template. That's all. Think of it like that. So the first thing we need to do is make a path to the save file. So that is, again, a location on your machine or computer. So we do that by saying string save path is equal to path combine, and we're going to pass the directory and the save file name. So that becomes our save path in its totality. Next, we're going to use try and open up some curly bracers here. And then we're going to say create the directory the file will be written to. Basically, we need to check if it's there, and if it's not, we're going to create it if it does not already exist. So we do that by saying directory dot create directory, and we pass not our save path, but path dot get directory name, and then our save path. Then we're going to say debug.log, and we can write a message here that will pop up in the console. We can say creating save file, and then we can just say at save path, and then we can pass our path. I'm just going to say plus, and say our save path, and that's it. So now it'll come up in our console, or the debug log in Unity, whenever we try to create a new save file. And now I'm going to make another comment, and I'm going to call this serialize, or rather serialize the C# game data object to a JSON file, or just to your computer. We can say into a JSON format. What does this do? As it suggests, it's going to write the data from C# to JSON. So we're going to say string data to store equals JSON utility.toJSON, and we pass our character data and we say true. And all this does is basically takes the data we've given it and converts it to a JSON file automatically, and there it is. Now we won't need to write that file to our computer after it's been converted to JSON. Now, how do we do that? We're going to say using file stream. I'm going to call this stream. And I'm going to say equals new file stream. And we're going to pass our save path. And we're going to say file mode.create. So what does this do? Well, it opens up a file stream in the mode of creation. So it allows us to create a file. And we are passing our save path because that's where it needs to create the file. Next, we're going to be saying using stream writer. I'm going to call that writer equals new stream writer. And then we pass the file stream that we just made. And then we say writer.write. And then we're going to write the data to store. And just to be very clear, I'm going to rename this from writer to file writer. So file writer.write data to store. So again, this just writes the file then on our computer. And the data to store is the data we just made, which takes our character data and changes it into a JSON. Then we write catch exception, and if for any reason there's a problem, let's write a debug log error, and then you can write some error message. I'll just say error whilst trying to save. Then I'm going to say character data, and you can just write whatever you want here as long as you know there's a problem. So what is all of this? Let's go over it really quickly. So we're establishing a path to save our file, and then we're changing our file to a JSON format so the computer can use it, and then we're writing that file to our computer. That's it. If anything else is confusing, it's just because of the syntax, and if you haven't used this before, any of this syntax or any of these functions, you're going to find these a little confusing. Don't worry, it's just one of those things you don't know until you know. So just read it over. I hope the comments make it very clear. So now we have a way to create a new file on our machine. So I'm going to make a comment here, used to create a save file upon starting a new game, or if you're saving an already existing game, of course, too, this would still be used. It would just overwrite the file you already have. So we're going to say used to load a save file upon loading a previous game. Let's make a new function, and we're going to call this load game. So let's actually make this a public character save data, because this is going to return a character save data to whatever it calls it. And let's call it load save file, actually. So let's open up some curly bracers, and the first thing we want to do is copy our save path from our previous function, because we can use that again. Except we're going to rename it to load path, because instead of saving a file to this path, we're actually looking for a file at this path. And what we want to do is grab that file and change it from a JSON back to something we can use in Unity. So let's call this load path instead. And let's make a variable right above that for character save data. I'm going to call that character save data, or just character data. And I'm going to initialize that at null because we don't have it yet. We need to get it from the computer from specifically a JSON file. So right below load path, I'm going to check to see if this file even exists by saying if file.exists at load path, then do some logic. And inside this if statement, let's make a string, and I'm going to call this data to load. And I'm going to initialize that just empty right now because it's not there yet. But let's then say using file stream again. And I'm going to say stream equals new file stream, pass the load path, and file mode is open this time instead of create because we're reading a file. So right inside there, I'm going to say using, and then we're going to say stream reader. I'm going to say reader equals new stream reader stream. Notice how we're using stream reader this time and not stream writer. I'm then going to say data to load equals reader.read to end. And again, this is stuff you just don't know until you know it. So you have to, if you've never experienced this before, you've never done this kind of thing before, don't worry about it. So next, I'm going to make a comment saying deserialize the data from JSON back to a file that Unity can use, or a format that Unity can use. So I'm just going to say back to Unity. So then we're going to say right here under the comment, character data is equal to JSON utility dot from JSON, and then we're going to make it to a character save data file, and we're going to pass our data to load. So that's it. It basically just, again, takes the JSON file you previously saved, and it just does what we did before, but backwards. It spits it back out into a character save data file, which then we can use in Unity once more. So let's make a catch here because we have a try, and let's pass an exception, ex. And what is that giving me a problem for? Let's open up the curly bracers here and say debug.log, and you can write a message here saying if you failed to load the data or whatever, you can say the file is blank or what have you. Why is this giving me an error? Ah, I see why. I didn't even write try. So I made a mistake. Let's just first say return character save data. And then right up here, let's save this. And in this if statement, or rather right below it, we should say try, and then copy all this logic and paste this inside the try. And then we can use our catch, and we can put our debug message or our warning if there is a failure when trying to load the file for whatever reason. I'm just going to leave mine blank for now. So let's save that again. And now we have the bulk of this done. So we have a way to write files and a way to basically load a file from a file that is written on your computer. So that's a large part of it done. But now this is not interacting with our player in any capacity yet. What I'm trying to say is we don't have it really connected, if you will. So let's make a header world scene index up here, just to keep this all neat. And this is under the world save game manager, by the way. And then I'm going to make another header for the character slots. Now, Elden Ring and Dark Souls have 10 slots, I believe. So I'm going to make a hardcode position for basically 10 of these slots. If you want to do an infinite amount like other games can do, you can go ahead and do that. You'll need to modify the code a little bit from the way I'm writing it. So I'm going to make a public character save data for character slot 1. I'm just going to copy and paste that for 10 total slots. So basically, you might have a situation where you make 10 characters and then you delete characters 6 and 2. So the slots for number 6 and number 2 are open, but the others are taken up. This is why I'm giving them specific slot numbers and specific slots. So let's save that. Now, we're not going to use all these just yet in this video. We're only going to use one. So for now, I'll comment them out. You don't have to, but I want it to make the focal point just this one slot for now, so you're not thinking too much about it. So don't stress about these yet. And then down here, we're going to basically write some more logic, or up here rather. Let's make a header for the current character slot being used, or the current character data. So basically, depending on which slot you load, it's going to feed it to this variable. So if you're loading slot 3, then the current character data being used is the data from slot 3. Hope that makes sense. Now, we also need a way to track which one of these we're picking when we start a new game. We're not going to do that in this video, but we're going to make the functionality for it right now at least. So let's make a new script called enums. And enums are going to be very, very useful in this series. We're going to be using them a lot for organization. So let's delete start and update. And outside of the public class, make public enum, and then call it whatever you want. I'm going to call mine character slot. So as it suggests, let's open up some curly braces here. These are going to be basically just an organization method of declaring which character slot we're using. So I'm going to say character slot underscore, or just character slot underscore 01, and then character slot underscore 02, and then I'm going to copy and paste that until I have all 10. You can do this with the number of slots you want. You don't have to have 10 slots. I'm just doing 10 again because Elden Ring and Dark Souls 3 specifically cap out at 10, I believe. So I'm going to do that so there is 10 slots. Okay, that looks good. Now, the reason why we're doing this is because when we start a new game, depending on the character slot being used, we need to give the save file a save name. So let's make a public character save slotter here, or just character slot, and I'm going to call this current save slot being used. So basically, if you're using slot 1, then the file name is going to be character slot 1. If you're using slot 2, the file name is going to be character slot 2. This also helps for looking for a file. We didn't know which one to look for as well. Now let's change load new game to load world, because this really just isn't loading a new game, so that name is a little bit misleading. So I'm going to call that load world scene. And now let's make a new function right above that, private void. I'm going to call this decide file name based on character slot being used, or rather decide character file name based on character slot being used. And as that name suggests, it's going to basically pass a name over to our save file data writer, depending on which character we're using. So we can make a switch statement here, and we can pass the current character slot, and that will autofill for us. And then based on that, we can write in some logic. And this is very simple. Again, we're just going to give the file a name based on whatever character slot we're using. So we can make a private string variable for the file name on this script too if you want, and we can pass that later. So let's make a private string. We can call that file name. And again, if we're using character slot 1, well, what do you want your character slot 1 file to be that saves to your computer? I'm just going to call mine file name is equal to, again, I'll just say character slot 1. And if you're doing this with an unlimited number of file slots, then you're going to want to basically make this dynamic and not hard code it like I am. So you have to make that a little bit different. So I'm going to say file name equals character slot 2 here, file name equals character slot 3, and so on and so forth. I'm going to do every character slot in this tutorial series. I'm going to do everything in this tutorial series. I'm not going to leave anything out. It's going to be a bit different than Dark Souls, where I just showed you to do one example and left the rest to you. In this series, I'm going to do absolutely everything, so the videos may be a bit longer. If you want to skip ahead, that's totally okay as well. For example, I'm writing out the same variable here essentially 10 times. So let's save that now, and I'm going to minimize this function. And next, I am going to make another function. So right below decide character file name based on character slot being used, I'm going to make a public void new game. And as this suggests, it's actually going to create a new game. So first we need to decide the file name for our new game. And then we're going to say current character data equals new character save data, because this is a brand new game. So let's just create a new character save data. And I'm just going to call this create new game is perhaps a better name for it, but call it whatever you want. As long as it's clear to you, that's all that matters. It has to be clear to you, not anybody else. Unless you're working with a team, then make it very general. So let's make a public void load previous game. And I'm just going to call this load game actually, and this is just going to be create new game, so that's pretty clear to me. I'm going to, again, decide the character file name that we want to load, because we got to target a specific file that we want to load. And I'm going to make a comment up here. So let's create a new file with a file name depending on which character slot you're using. And then down here, we're loading a previous file with a file name depending on which character slot you're using. So basically, if you can't tell yet, all that enum does is it just tracks specifically which file we're looking for in a more neater way. You could use 10 bools, but that would be pretty messy. So it's just better to use an enum instead. So let's save that and go to the save data file writer. Delete the mono behavior. This doesn't need to be a mono behavior, nor should it be a mono behavior, because it's not being attached to anything in the game either. It's just something we're referencing and using like a tool pretty much. So let's make a header for our save data writer. And let's make a private variable for this data writer here. So we called that save file data writer, and I'm just going to call that save game data writer here, or rather save file data writer. And then down here, I'm going to say save file data writer equals new save file data writer. So basically it's creating one on the spot here to use. And then we can use the functionality we have inside of it. So we can say save file data writer dot save directory path is equal to application dot persistent data path. So what is this? This is basically a general data path that you can use across many machine types. So I'm going to make a comment here that says this generally works on multiple machine types. So this is a safe bet to use when you're basically making a save system, because it works on multiple machine types. That's it really. So we're assigning the save directory path to application.persistent data path, and then we're going to say save data writer.file name, or save file name, is equal to the file name we have specified. So again, depending on which character slot you're using, this file name will be different every single time. So depending on which character slot you're trying to load in this case, it will load a specific file name. Then we could say current character data equals save file name dot, whoops, not save file name, that should be save file data writer. And then we can say dot load game. So again, you look for a specific file in your computer, and then it finds that file and it loads it back into a character data. So you see how it's all connecting now? It all comes together. Next, finally, we start our coroutine for load world scene, and that is how we are going to load a game in the future. All right, so that is working as intended. I think. We'll test it in a moment. So let's make a public void for saving game, because we have a load game now. And apologies if you can hear my dog. He's being a little bit noisy. He's making old man noises in his sleep. Let's say decide character file name based on character slot being used. And again, this will save the current file under a specific file name, depending on which slot you currently have in use. So again, the enum is coming in clutch here, and it's being very handy in dictating what we, or where we save our file, specifically what we call it. So we're going to say save file data writer is equal to new save file data writer. So again, we just create one to use, just like a tool, if you will. And then we're going to say save file data writer dot save path equals application dot persistent path, and then the save file name is equal to the save file name. So that is the same as above. And then we're going to say save file data writer, but instead of loading a file, we're going to write, I believe we call that create a new character save file. So if you're saving in an already existing game, this will just overwrite it. And we're going to pass our current character data. So that is mostly it. We need one more thing. We actually need to pass the data on our player's object to our current character save data, so that when we write it, it has the data from that character. So if our character's name is Leopold, for example, we got to tell the save data, hey, save data, this character's name is Leopold. And then the character save data gets written from the save file data writer to our computer. So let's make the function now to pass the player's information from the game to their specific save file. So I'm going to go over here now and make a player variable, player manager variable. So private player manager player. And now let's basically go to the player and make a function for passing that information. So I'm going to call the function save game again, because this is going to be called when the game saves. And it's going to take any information that we want to save from our player and pass it to that character data file. So public void save game. Let's open up some curly bracers and a public void load game in the future when we actually load information from a save file and pass it to our player. So what do? I'm just going to call this save game data to current character data, so it's super clear what this does. And this one is load game data from current character data. Again, super clear as to what that does. There should never be a mistake in the name there. So inside here, let's first actually go to our world save game manager, and let's call this function now. And we're actually going to make this require a character save data variable as well. So come down here in save game, and let's say player dot save game data to current character data, and let's make it require a current character data variable. Now we need to pass this by reference. What does that mean? Well, we need specifically not any character save data variable, but the specific one that is being used right now. So make sure you use the keyword reference for that. If you don't know the difference between pass by reference or pass by value, I will leave a video in the description explaining. Now we want our character name to be visible in the future by other cooperative players. So instead of making a regular string, we're going to make it a network variable, and we're going to use a fixed 64-byte string. Now we want to first say using unity.net code on our player network manager, so we can use network variables. And also, we're going to need to put in another library, because right now if we try to type public network variable and we try to type in fixed 64-byte string, you can see it's not going to pop up. So right below using unity.net code, let's add another library. So we're going to say using unity.collections. And now we can say, I believe it's called fixed 64 bytes. So okay, it's fixed string 64 bytes. So we're going to call that character name, and we're going to initialize that as a new network variable, fixed string 64 bytes. And then I'm going to initialize it a character. So defaultly, if this doesn't change, it starts off as character. Network read permissions is everyone, and network write permissions, as usual, is just the owner. So this is going to be the name given to your character after character creation. And I'm getting an error. Oh, that's because I think this is depreciated because I forgot to put in bytes. Yes, okay. So there we go. Now let's save that. Now let's go back to the player manager, and we can say current character data, which we called current character data dot character name is equal to player network manager dot character name dot value dot toString. You need to use dot toString to change it back to a regular string, and you need to use dot value to reference the actual value of the string itself. So then we're going to say current character data dot y position equals transform dot y, and then the x position equals transform dot x, and then the z position equals transform dot z. Probably should have started with x on that one. My bad. I'll correct that momentarily. But basically, we're just filling in every bit of data on the current character data sheet with all the data we have right now on this actual player game object. And then in load game data, it's the reverse. Instead of saying current character data dot character name, we actually assign our character name by saying player network manager dot character name dot value equals current character data dot character name. So just take what you did with save and reverse it. So you can make a vector 3 for this if you wanted to by saying vector 3 my position equals new vector 3. And then we pass our x position, our y position, and our z position. So essentially on one, obviously, we're going to write data to save. And on the other one, we take the data we're being passed and we write it to our character itself. So in the future, if you had your stats like vitality and endurance and stuff, you would just say my endurance equals character save data dot endurance. Versus on save, you would say character save data dot endurance equals my endurance. So yeah, vector 3 my position equals new vector 3, and we pass all that. And then you can just erase the current character data down here. I'm going to reorganize that too so it goes X, Y, Z. So it's in the proper order. And that's it. So let's save this now, and we're almost ready to test it. Oh, and you have to say transform.position is equal to my position, obviously, to actually assign position. So let's save that. Back to World Save Game Manager. Let's come up to the top here, and I'm going to make a header for save load. This is just a quick way to do it until we actually write in saving with interactions. So let's make a serializable field for bool save game, a serializable field bool for load game. And basically, we're going to make an update function. And if these bools are checked in the Unity editor, then we'll save and load the game forcefully. But we'll make a more dynamic way to do that in the future, specifically when you do key events like interact or kill a boss or kill a monster, etc. So if save game is equal to false, and then save the game. And then if load game is equal to false, and then load the game. That's it. Okay, let's save that again. And I'm going to minimize all these functions, save this, go into the inspector. I have an error. I forgot to use the keyword reference here. So just say ref current character data. All right, save that again. Now I'm going to go to my title screen canvas and hit the title screen manager. And where we have start new game, I'm going to say world save game manager.instance.create new game. In the future, we're going to check for a file first, overwrite anything, yada, yada, but let's just jump in the game and see if it works. So I'm in the game, I'm going to hit save game, and I get an error. And that is because the player manager object on our world save game manager is never initialized. So let's go up here and make that a serializable field just for now, and let's drag it in manually to make sure this works. Okay, so let's put serializable field, save that game, and then go back to the game here, start it up, go into the game. I'm going to jump the scene. Here we are. So let's drag it in, and now we save the game. Boom. There we go. You can see the file saves, and look what happens to our inspector. The X, Y, Z position all populate, and the character name is filled in. So we have a functioning saving system. We need to heavily expand upon it, which we're going to do in the next episode. So we're going to begin by adding support for multiple slots, and we're going to obviously showcase loading these specific slots and overwriting and creating new slots, etc., etc. Now, what I want you guys to attempt to do is use the knowledge you've amassed from these episodes so far, and I want you to think to yourself, how would you initialize that player manager variable on the world save game manager? And by that I mean, how would you declare it? What would you do? How do you know which player is the local player? So think about that, and I want you to see if you can fill in that variable yourself. Tell me how you would do it in the comments if you'd like, or maybe don't, because that would spoil it for other people. But yeah, I'm going to show you how to do it in the next video, but just to get your brain thinking, if you're new to netcode, go ahead and try to fill it in yourself. And I would just like to say thank you for tuning in with me every week. I'm having a lot of fun. I hope you guys are too. I hope you're learning a lot. And if you made it this far, as usual, would genuinely appreciate a like, and a comment does help the video out a lot. Thank you to all of you who take the time to do that. And as always, a special thank you to my Patrons. I appreciate each and every one of you so much. Genuinely, I do. I'll see you guys in the next episode next week. Have a wonderful weekend.